Natural uranium contamination in major U.S. aquifers is linked to nitrate. So we're going to see what they found at ACS Publications. Uranium contamination of groundwater has primarily been associated with anthropogenic activities such as mining, milling, nuclear testing, and disposal of spent nuclear fuel. However, groundwater with U concentrations across the United States exceeds the U.S. Environmental Protection Agency, MCL, of 30 picoliters in many regions, including those without anthropogenic U activity, indicating a source of natural U contamination. This is significant because the consumption of U-contaminated drinking water has been linked to nephrotoxicity, osteotoxicity, and thus poses a health risk. Also, the High Plains, HP, and Central Valley aquifers, two of the largest and most productive aquifers in the world, are among aquifers with high concentrations of dissolved U in groundwater, and the two aquifers represent a common aquifer type. Unsolidated sand and gravel composed of slit sands and poorly sorted clays, gravel deposited through weathering and alluvial processing, and providing drinking water to nearly 6 million people. And in addition to being an important source of drinking water, these aquifers are also mined to irrigate, of cropland accounting for all of the U.S. agricultural and annual revenue. And drought has placed an increased reliance on groundwater, impacting not only the quantity, but the degradation of the groundwater quality as well. And uranium is ubiquitous, naturally occurring radionuclide, common deposited as a degenic secondary mineral in organic carbon-rich regions subsequent to weathering of indigenous plant materials. And the majority of U exists in soil sediments and insoluble reduced minerals, uraninite, which may be associated with volcanic rocks, black shales, or orgonite. And nitrate is commonly found in groundwater, primarily originating from the surface-applied chemical and animal waste fertilizers. Nitrate also plays a role in U solubilization, leading to the secondary U contamination. Biological nitrate reduction coupled to the oxidation of organic matter can generate alkalinity, mobilizing UIV. But generation of alkalinity alone cannot account for U solubility if they originated as U mineral. Nitrate can also abatically oxidize minerals, yielding aqueous, and abatic and biotic nitrate reductions will also produce reactive intermediaries such as nitrate, nitrous oxide, which will abatically oxidize. And nitrate-driven oxidation reactions can produce reactive Phe, oxidize it, and that will also oxidize, and reduced minerals can also serve a microbial energy source where oxidation is coupled to nitrate reduction. Thus, nitrate is a primary groundwater contaminant, leading to a factor linked to secondary U contamination. And they took a look at that and the uranium concentration metadata. What did they find? The assembly of metadata included the data points from multiple sampling locations in 9 states: Colorado, Kansas, Nebraska, New Mexico, Oklahoma, and South Dakota, Texas, and Wyoming, and CV California aquifers before exclusion and truncation of location coordinates. The metadatabase was assembled from groundwater sample data with reported numerical latitude, longitude, and collection date, nitrate concentration, and or U concentration, analytical detection limit required inside the boundaries of HP and CV aquifers. In the event of duplication groundwater sample report, same sampling location on the same day with the same nitrate or U concentration, only one sample was included in the metadatabase, and after exclusion, the metadatabase was reduced to groundwater samples from the HP and CV aquifers as well. And we can find the results and the information right here. So, is it linked to it? It definitely looks like it is, and this could be a huge issue for U.S. aquifers. So it's a good idea to periodically test for uranium if you suspect that this could be a problem.